Okay, in this video we're going to have a look at displacement reactions, but we're now going to try and look at it from the point of view of a redox reaction. If you remember, redox is all about understanding that oxidation is loss of electrons and reduction is gaining electrons. And we use this term, oil rig, to help us remember that oxidation is loss, reduction is gain. So let's apply those ideas to this work that we're going to look at here. So in your books, this is the page from your book. Bits of questions. It says describe what's meant by reduction, describe what's meant by oxidation, what's meant by redox. Remember, redox is reduction and oxidation happen at the same time. This is the bit I want though. It's going to give us an example to have a look at. Okay, so the example says that zinc is going to react with copper sulfate. If we get our reactivity series, we can see that zinc is more reactive than copper because copper is way down here. Okay, so I would expect this reaction to take place, and what I expect to happen is I would expect that the zinc would displace the copper, so I would get zinc sulfate forming as a compound, and I would get copper being displaced, pushed out over here because it's less reactive. In terms of formulas, I'm going to put those in. So copper sulfate is CuSO4. Remember, SO4 is a sulfate. Zinc sulfate, ZnSO4, and copper is Cu. Okay, I'm going to add a line into this now, and my line I'm going to add into this, I'm going to split these, particularly the two compounds, into their separate parts. So here I have got zinc, and then copper is a 2+ ion, and sulfate is SO4 2-. So the compound copper sulfate is made up from Cu 2+ and SO4 2- ions coming together. That's going to form zinc sulfate. Again, let's split this. So it's Zn 2+, and we get a sulfate SO4 2-, and then we get copper being displaced. So all I've done here again is split this compound into the ions that make it up. Now, if you have a look at this carefully, you will notice that some of these ions and elements have changed, some of them haven't changed. For example, if I look at zinc, zinc here is Zn, but on this side of the reaction, it has become Zn 2+, it's become an ion. So that's changed, I'm okay there. Copper 2+, and then on this side it's become copper, so there's been a change. The sulfate is SO4 2-, and the sulfate here is SO4 2-, so the sulfate hasn't changed. So to help me, what I'm going to do is I'm going to get rid of anything that hasn't changed from the reactant side, the left-hand side, to the product side, the right-hand side. Okay, so sulfate has stayed the same, so I'm going to get rid of it, but everything else that we've just described has changed. Therefore, this equation becomes Zn plus Cu2+, I'm going to ignore the sulfates, goes to Zn2+ and Cu. Okay, that's what we've got. This is called the ionic equation because now our equation contains ions, charged particles. From this, I'm going to split this now into two parts. I'm going to look at the zinc as one part, and look at the copper as a separate part. Let's deal with copper first. So copper starts off as Cu2+, and it becomes Cu. Okay? Let's ask ourselves, how does it do this in terms of electrons? If we go back to where we started at the beginning of our definition, that oxidation is losing electrons, reduction is gaining electrons. So how does this change? I've gone from a 2+ ion to an element with no charge. So to go from 2+ to something with no charge, I've got to add electrons to this side to make the 2+ become no charge. And I'm going to need to add 2. So I'm going to add 2 electrons here in order to make the copper metal form this side. Because I'm adding electrons, this reaction is reduction. Okay, let's look at the zinc. The zinc has gone from Zn, and then it's turned into Zn2+. How's it done this? Well, to go from something with no charge to something with a positive charge, you must lose negatives. You've got to release negatives. Okay, so I've got to lose negatives. Those negatives are being lost as the ion forms, so there they are getting lost. If this is being lost, oxidation is loss, so this is an oxidation reaction. And you can see that with these two reactions going at the same time, we have reduction and oxidation, therefore we have a redox reaction. So displacement reactions are examples of redox reactions. They involve the movement of electrons, the transfer of electrons during that reaction. Okay, in your notes, we've started this off here. You can now transfer this information to here so that you can complete these notes and explain it. And then on the next page, page 32, there are some questions for you to try yourself. I'm going to suggest you have a go. I'm then going to put the answers in, and you can then check your answers against the answers that I've given to you. Okay, good luck everyone.